All right, here is the tube collection. All right, let's do a little quick scan of the whole thing first, then we'll look at some of the tubes. All right, when we look at this, if we start right here and we go to right there, that is 22 feet. It's 22 feet, and then if we go from right here down to about here, that's about 5 feet. We got 2 more feet down there, 7 feet total from the floor to the ceiling. All right, wow, look at that load of tubes. Load of tubes. It just absolutely beyond comprehension. Here we have common tubes down below. We got thousands of them, just ugh. All right, we'll go back and look at some of the tubes in a minute. I'm just getting an overview. So, you think that's a big tube collection, huh? Well, just when you've seen them all, but wait, there's more. Let's go around the corner. Oh my goodness. Another 22 feet of tubes by 5 feet. About 3/4 of these tubes were donated by a fellow named Carlton. And then we had a couple of other people who've donated and added to the collection. All right, here, let's look at some of the tubes up close. All right, here we have some reflex klystrons, traveling wave amplifier. There were 2. We got 2 of them there. Couple more reflex klystrons. Couple little micro ceramic tubes. Okay, and here we have our miniature tubes. These are all of our little pencil tubes. Various triodes and pentodes and stuff like that. Some of them are pretty crazy. This one here has got connections on the little rings there, and then connections for the plate and the filaments down at the bottom. Another one, that same basic kind of construction, but a different number. Here we have a microwave tube. This one will oscillate up into 2,000–3,000 megahertz in a proper cavity. And this one here is a solid state equivalent. This is equivalent to a 12AX7. It's made with field effect transistors and just plugs into a 12AX7 socket, and unless you have a solid state replacement. Here's our standard nuvistors. Here's the little nuvistors. Here we have a microwave tube of some kind. This is a microwave oscillator here. It runs at 1.7 gigahertz. And here's another microwave tube. This one here is our little Western Electric, the 715 microwave tubes. This is a klystron. This is an open cavity klystron. The cavity connects to these 2 rings, and it can be tuned over a wide frequency range. This one here, no idea what it is. I got a couple of them. It's Russian tube of some kind. I'll have to play with it to see what it is. Okay, now this one here is a spark gap tube. It's used to protect a receiver. Okay, this is a Marconi, a little triode, early Marconi. Okay, these are ceramic microwave tubes. Okay, this one is a Geiger tube. And this is a flash tube down here. This is another Geiger tube. Here's one of the little flat matchbox tubes. Okay, now we wouldn't be, we had to go ahead and have a few semiconductors in here. This is our early diodes. This stuff is all very early. There's a few modern ones. These are the more modern ones here. But all this stuff up here, these are from back in the 50s where, they were just getting started in it and they hadn't figured out good packages yet. And they were doing all that expensive packages. Now the only thing you can get is the molded packages. Okay, more diodes. These are high voltage diodes here. This one here's a selenium high voltage diode. If you look carefully, you can see they're just stacks of selenium, little squares of selenium diode rectifiers packed in there. Just like a regular selenium rectifier, like these, but the individual plates are just stacked one on top of the other. And it's made to be immersed in oil. And this one will run, it calculates out to around 4,000 volts. Okay, now here we get down into the early transistors. Here we have an early, some of the early CK721, I think that is similar to a CK722, but it's a little bit later. And the numbers are not in order, of course. They, for some reason, just randomly numbered them. More early. These are all very early transistors that are no longer available at all. Now here we have a few modern ones. These are the modern cases that you get nowadays. With some of these cases you can't get it. You couldn't get it if you tried. You'd have to, might find something on eBay occasionally. Here we got a couple of them that cut open just to where we could see what's inside of them. And interesting to look at them with a microscope and see all the stuff. These are RF transistors. This one here is good for a watt at 2.2 gigahertz. This one's lower frequency. This one is about 50 watts at up to 50 megahertz. And some of these are cable TV. They're good for a watt or two up to 500 megahertz. Okay, then down here we got a collection of selenium rectifiers of all the different sizes and things. Each plate on this is good for 20 volts. They break down at about 30, so they rate them at 20 volts. So that's 20, 40, 60, 80, 100, and 120 volts. That's RMS. And that would be used in a line-operated like TV set or something like that. And the larger the area, the more current they can take. Now these are high current ones here. These are copper oxide. They're not selenium. These are copper oxide. And they're good for, I think, about 5 volts per cell. And these things have a low enough internal resistance where you can run a couple amps through it. This one here is good for 2 amps at 120 volts. So it's a pretty powerful rectifier. It's got all those stacked up together. And then this one's another copper oxide type rectifier. This is, I think, 10 amps at 24 volts. And then here's a bigger one. It's same thing. Now this one is selenium here. So it doesn't have as much current capability. Even though it's a bigger physically, it's only good for an amp or so. Okay, here we have a CRT from about 1928 or 29. This is one of the earliest CRTs. It has no deflection plates or anything in it. It has no place to put a yoke. It just has the electron gun. This one's been damaged. It's been glued back together. But it's just the sheer age of it. This thing coming from back, almost 100 years ago. It's one of the earliest CRTs that was ever made. Quite a find to get that. And then here we have a couple more. It's another klystron. These are TR tubes. They are used to short out the transmission line when you do transmitting. Okay, here we have another. This is a backward wave oscillator here. It will oscillate at somewhere around 2 to 3 gigahertz. This is the inside of a backward wave oscillator. It's got the little spiral there, and all of that fits up inside of a magnetic housing. Okay, here we have Vidicons, various Vidicons. Each one is different. Big ones and littler ones. Here we have flash tubes, and then these are Gessler tubes. And then up here we have some flash tubes. These just give a brilliant flash, like flash bulb. Okay, and then here we have an ultraviolet tube. Here we have a microwave oscillator, about 1.7 gigahertz type situation. This one is an environmentally protected tube. The tube is up inside there, and it's in a hermetic case. Here we've got a radiosonde transmitter. Okay, transmitting tubes. Okay, we'll go along the top row first. Okay, these are all the bigger transmitting tubes. These are thyrotrons. Thyrotrons. This is a microwave oven magnetron. Here we have a huge thyratron. More thyrotrons. This is one of the common 715C radar pulse modulators. This one here, now this is a unique tube right here. You'll never see another one of these ever. You know what the glow tubes are? Let's look at a glow tube. Here we have your common OOA and OA1 and OA2 and things like that. Well, this is a giant one. Look at the size of that compared to my hand. It's 4 inches in diameter, and it's about 5 inches tall. And when you fire it up, the whole internals of it glows blue. And it's a glow discharge regulator. Now, this one here, this is a rectifier. You'd think that might be a transmitting tube, but it's not. It's a rectifier tube, high voltage rectifier. And this is an odd looking thing. It's got 2 plates side by side. It's another thyratron type tube. All of these are thyratron type tubes here. Okay, here's another hydrogen thyratron. All right, let's drop down a level. Okay, here we have some kind of Telefunken. That's German tube. It's a triode. Triode or... No, this one's a tetrode. This is a tetrode. It's hard to see the fine grids inside there on the camera. Okay, this is one of those magnetically shielded... it has a 199 inside of it, and then it has that magnetic shield over it. That's made out of cast iron or something, or steel. Okay, and then here's some more antique thyratron type tubes. Here we got another powerful triode here. Old-fashioned type thing. You don't find them anymore. They don't make that anymore. This one is a 150,000 volt rectifier tube for an X-ray machine. It's submerged in oil, has to be submerged in oil to take the full voltage. Here we have a power triode. It's a 500 watt. Okay, here we have a Burroughs regulator tube of some kind. Okay, here we have some of the planar triode. This one here is a klystron. The klystron cavity fits between these 2 rings. It's a reflex klystron. This is the reflector, and cathode and stuff's below. This is a 2K50 klystron, reflex klystron. It's electronically tuned. Okay, this is your common 2K25 klystron. This one is a British klystron. Has an output. The output of this one is a waveguide. Okay, this is a discharge, spark discharge tube. It has 3 terminals and little balls that are placed very close contact. They don't quite contact. And then it's got some kind of gas in it. And it breaks down at around 60 volts and clamps those electrodes together. This is one of the early magnetrons. This one operates in the 200 to 400 megahertz range. It's a low-frequency magnetron, if you can imagine such a thing. This is an old-fashioned... it's had some trouble. Oh my goodness, it has definitely been dropped. Oh boy. This is a Singer Audion DeForest. It's made, this is a diode here. They made a diode and they made a triode. A couple of microwave, or not microwave, but UHF power tubes. And another one, this is a, this is a planar triode. This is a open cavity klystron. That's very common. Okay, this one is a vacuum measuring tube. These are interesting tubes. Look at that thing. It looks like a top hat there. It's sealed. And here's what's inside of it. This is the plate, this little piece over the top, and you can see the cathode goes right through it, and then the filament goes through the cathode. It's a diode. And it's obviously made for pretty high frequencies, but that big can on the thing just kind of, what would you use it for? It's a zirconium arc lamp. The arc forms here. It's brilliant, just like a white hot spot there. These are Tungar glow rectifiers. These are some small ones. They're rated at 1 amp or so. And here we have some more Tungar bulbs of various sizes and shapes. And this one here, the glow is inside of that box. And then these are the anodes on the outside. And there's slots in that box where it flows out. How in the world they would do that? Oh my gosh. And here's another one, same basic scheme. You can see in the envelope there's a slot, and the current comes out of there. Why did they make that way? Is the slot the right size, or did they just guess? Who knows? Another brand new one. It's got a clean envelope. Now this has got tremendous current capability, but these, normally when you find these, they're black looking because the envelope has been darkened from use. All right, let's go the next row down. Okay, here we have photomultiplier tubes. Okay, we have various tubes of different sizes. They have the light input on the end, and then they have the electron multiplier assemblies down inside. Now, this one here is a spectrum tube. The top has got a clear lens in it. It's clear and flat, and this part here glows, and it has a certain type of gas in there. Let's see, spectral output, and it says, oh, this is a neon one, okay? See, the gas it says neon. So this one here glows orange and gives the spectrum of neon. These are power rectifiers. Another hydrogen thyrotron. Now this one here is a photocell. Unfortunate, no, that's the input right there. It's hard to see on the camera. It's got a clear spot in the plating in there to where the light goes in there. And okay, here we have a couple of photomultiplier tubes. Here we have side-on photomultiplier. The light goes in the side on these. This one here is an infrared photomultiplier. It's the same tube as this, but it's for infrared only. So it's blocked to visible light, but if you shine infrared on it, it goes through that black coating and is amplified. Now this one here is a image intensifier tube. It has a microchannel plate on it. It has that crazy look to it that it just, you can see it almost looks like it's kind of glows down inside there. Okay, then this one here is a big ignitron tube. It's a couple hundred amps. Oh, here's a really odd one. Okay, you know the OB2 that looks like this? Well, there's a version of it that also, that is an OB2. It has the same characteristics as an OB2, but it's a 7-pin miniature base. Oh, okay, here's one that's ultra special. Look at that tube. That is really something. Now, you might wonder, what is that rod out the top? It is, when you move that rod, there's a flexible diaphragm, and you can see when I move the rod, the plate moves inside the tube. This is used in like seismographs. When this is vibrated, it causes the signal in the triode to change in proportion to the position of the rod. And that gives a very stable, highly sensitive sensor for vibration. Here we have a couple of little mushroom tubes and more little tubes. This one here is another ballast tube. You see it's got the wires in there. Okay, this one here is a dual triode, and the two plates are brought out on the top. And then the others are a triode, single triode, and they bring the grid out on one and the plate on the other. Here we have our common old 829B power tube. Now here's 829B that's in a socket that has the push-pull coil on it, and the output push-pull power triode. It has dual triode, and it's got the plates brought out on the top, so you can make a nice tuned line on it, or just the coils. And here's a more powerful one. This one was used to drive this one. This one put out an output of about 20 watts, and this one puts out about 100 watts. So they used this one to drive this one in a grounded grid circuit, and it gave a total output power of around 120 watts. Another Russian tube, I don't know what it is. You can't see inside of it. It's got bases, 4 pins on it, so it could be a triode. A little lower, next layer down. All right, here we get into magnetrons. These are cavity magnetrons, missing the magnet. This one here has the magnets, and it's probably good. The filament reads good, and it might be good. We'll fire it up. This is an oscillator assembly. It's got a 2K25 in it, and the probe sticks out the bottom. This one here is a low frequency magnetron. You got your 2 input here. The high voltage goes onto here, and the output is on this probe right here. And this one oscillates down in the below 1,000 megahertz type range. I think this one is up to air. I don't know for sure, but I think it's up to air. This one here is for sure up to air. Oh, no, this one is not up to air. The filament's burned out. This one has no filament. This is a klystron oscillator. These two here are the walls of the cavity, and this one here is not disassemblable. The cavity is made onto the tube. So I don't know if it's still good or not. I'll have to test it and see whether it still has vacuum in it. Here's a small magnetron, cute little small one. This one's good. This one's in good shape. We'll demonstrate it. Phototubes. These are all different types of phototubes. They're just diode phototubes, and every different size, shape. This one here is not a vacuum type. This is a cadmium sulfide. And then more vacuum tube types. All the different numbers and shapes of them. Then we get into some taller ones and skinnier ones, and then get into another one. We've got one here that was a duplicate. I was going to get another one for it. And here we have an end-on one. It's got a cup-shaped sensor. Okay, then here, a couple cadmium sulfides. Now this one here is a vacuum photodiode. It's sensitive from about 2 microns, which is infrared, near infrared, all the way up into the ultraviolet. Okay, then here we have these little cartridge type phototubes. This is an end-on phototube. The light goes in the end. And now we're getting back. Here's another photomultiplier. This is a small one, has very few stages. It's maybe 3 or 4 stages. It gives a lot more signal than a plain photodiode, but it takes a lot less electronics to get going than one of the bigger ones. Here you have to have a whole string of resistors and stuff to set the diodes. Here you only have 2 or 3 diodes, so it takes very few little parts. Okay, here we have one of the smallest photomultiplier tubes. This one is 3/8 inch in diameter. These are what's used in a CAT scan machine. You see that big machine that takes the picture for X-ray ones. Here's end-on ones. Little end-on ones like that. Very, very rare tubes that you don't find. Here we have some little itty-bitty ones. You see how small it is compared to my finger. Okay, going down. Here we have eye tubes. Okay, this is a British eye tube of some kind. Here we have some eye tubes that are, they're not really eye tubes. These are just fluorescent indicator tubes. Okay, then we get into the more common looking really eye tubes. Each one of these is a different number. These are foreign ones here. They're from Britain. This one here, it's recessed. The glass is recessed for some reason. I don't know why. This one's just flat across the top, and these are just domed like normal. And then here we got some more. Here we got a fat one. This is another British made. Here we have the old ST style standard tube. This is plain. Here's a brand new 6E5. That's about as good as you can get. I mean, that thing is just as white as a sheet in there, which indicates the phosphorus is good. Then we go, here we have little bitty ones. Look at those. Little bitty ones. I got one that's even smaller than that, that's in a box somewhere. I've got to get it and put it on here. There's one that's even smaller. It's smaller than that even. And I've got one. Okay, this one here, the shadow moves sideways instead of in and out or spreading. And then this is the short one. It's got two shadows on it. Okay, these are the ones that have the bar that just gets wider and narrower. Okay, and then here we have standard type. One of them I don't have is a 6T5. I think I have a 6T5 in a box somewhere, and I'll get it and mount it. I got room for it here. Okay, here we have a flash tube of some kind. Here we have a couple strange tubes of some kind. They're triodes. High frequency stuff. The elements are placed very low down, close to the pins, so that the tune circuits can be mounted really close to it. Here we have large acorn tubes. That's an acorn and a half tube. Okay, and here we have an actual acorn tube socket. This is a tune cavity that is made to work with an acorn tube. And I don't know what the frequency is of it or anything. We'll hook it up and make it work. But this is an actual socket for one of those giant acorn tubes. Now here's some fat little tubes. They're foreign tubes. I can't tell who made them, but they're either German or British. And you can see through here, scraped off the coating on one, so you can see it looks just like a regular tube inside there. But you can see from the height of a couple fingers, it's very short. Now down here we have our Nixies. Okay, these are more of those counter tubes. They have the little pins that glow. This one's been used, and it's black in the front. You can hardly see the pins inside. Now when it's glowing, you can see them pretty good. Now this one's brand new, so it has no significant darkening. Okay, this is one of Dalibor's tubes here. This is one of the big Nixies that he makes. Okay, and then here we have standard Nixie tubes. These are just common commercial Nixie tubes. Let's go over here. All right, first we'll go to the big ones. Mercury vapor tube, mercury vapor rectifier. So it's pretty common type of tube. Okay, we've got 3 different versions of it there. Okay, here's another. Okay, this one here is another X-ray this is an X-ray rectifier tube. It's not an X-ray tube. It's used to change the high voltage to DC in the DC machines. A big ass-kicking power tube here of some kind. There's another one, probably good for 500 watts. Look at that one there, how it's got holes in the plate. It's just this is an old-fashioned tube. This is from in the 20s. Here we got one, it's called a Songbird. Songbird detector. Very unique, hard to find. Here's some of the DeForest ceramic base tubes. And here's one that's a foreign tube. It's got the tube mounted sideways instead of up and down. Oh, and look at this. Oh, look at that. Not many of you know what those are. Those are the German multi-element tubes. These are like the I can't remember, E something or another, tube number. And it's got 3 tubes built inside there. And all of these little modules here that are sealed in glass are resistors and capacitors. And it's wired up inside there, so it's actually a 3-stage detector. It's a detector and 2 stages of audio amplification built into the tube. And this one is in good shape. The filament's all measured good, so we'll go ahead and we'll show that off working. This one here, the getter's pretty much covered all the good guts. But we'll build a radio using the tube. We got one socket. I've got one socket here for that tube, and that'll be good for building a radio using a tube like that. I'm going to make one of those in my tube shop, and I've got the model right now. I got the model right and see exactly what it looks like. A DeForest transmitting tube, very, very collectible DeForest transmitting tube. Here we have some other kind of transmitting tube. That one's got a screw base on it, and I don't see where. I'm betting that's a rectifier, because there isn't any third terminal for the grid. So it's probably a rectifier or detector. Okay, here we have a, oh my, it's a, I can't remember what it's called, a gyrotron or something like that. It's a, okay, here we have some of the Canadian triode tubes. Oh, some spherical audience, homemade in my shop. Here we have detector diode, a Fleming diode. Okay, here we have a couple of British, got that foreign base on them. Hard to find the sockets for those. I've got some that are for a larger one, but the smaller one I don't have any sockets for. Here we got some kind of a resistor in that one there between the plate and the output. There's a resistor of some kind. And I don't know if it's good or bad. It looks bad. If you look closely at it, you can see it looks eaten up. But we'll find out. More foreign tubes. And it's something the way they put those beads on there for some reason. Made back in the 20s. And it was made to get around the patents that were on the standard cylindrical triodes there. And then here we have an odd looking one. This is a Atwater-Kent rectifier tube. This is a solenoid tube, uses a magnetic field to modulate the signal. Here we have a 2-section tube. This is one of the earliest multiple section tubes, and has a triode and a tetrode in the same envelope. Here we have a wire element pilotron, homemade in my tube shop. Some more odd. Here we have, this one here is very rare. It is a metal Type 45. It's got a metal can around it. Here we have high voltage rectifier. Here we have a tennis ball tube. That's a 101D. Here we have an experimental tube that was made in my tube shop. The filament goes right through the center of those plates, and you know, it's just a way of making a tube that beats the patents. They made this tube to beat the patent on the standard tube. Now here we have a blue. This was I tried making a triode tube using blue glass. And boy, you talk about hard to work. This stuff is really difficult to work. These are all old tubes here. These are not modern tubes. These are from the 20s, 101Ds and stuff like that. And these are, I don't know what the number is. They're old. Here's some gold tubes. Old. Heaven only knows what's inside there. We'll get the X-ray machine and we'll X-ray it one of these days. Okay, here's another triode. Triode. Look at how that triode is. Big aspect ratio there. Just spacing and stuff. Another odd shape that the Europeans made. They had that. I think that was tapered like that so that they could pull it out of the mold. Okay, here's some more of them. These are those glow discharge rectifiers, like type BH and things like that. Got several different versions of them. Just going along. And here we have a tetrode, power tetrode. If you look carefully, you can see up inside there's two grids. And I don't know if this one's good or not. This is an actual commercially made one. Holland, made in Holland. Okay, here we have what's called a 4-pillar tube. I don't know why they made the pins that long, but they did. And we got another one here. It's the same thing, 4-pillar tube. I got connections on the side for something. Okay, here we have a bunch of European metal tubes. They used aluminum, I guess because it's easy to form. Here we have the foreign spray-coated tubes. These are sprayed and they're painted. And heaven only knows what is in there. And some of them are pretty odd shaped. We got a big fat one in the back there. Comes down and then neck down to where it fits in a little bitty standard socket. And here we have those foreign tubes that fit in those sockets that are the radial. Hell, get out! I can't get it out of there. They don't come out. Here, maybe this one will. No, you can't get them out of the socket. I don't know. They snap in that socket and they're held to get out, but the pins stick out the side on the base of the tube, and they click down in there and it grabs it really tight. It's kind of a European version of a Loctol. Okay, here we have a European one that's built sideways. The elements are horizontal, where you can look up inside there. This one looks like it's got a good filament. It might. If it does, we'll operate it. We'll make it work. Okay, that's a Type 80. It's just out of place. No, it isn't. It's not out of place. This is a Type 80 European. Has that type of base on it, the one that has the pins out the side. And then here we have like a Type 45 and that kind of a base, and like a 6X5 or something like that. And here we have that's an odd-looking rectifier. It's equal to a Type 80, but it has a screen plate. And here we have a plain old 80. I mean, that's as close to an 80 as you can get with that odd base on it. And here we have more of those. Okay, here we have this is a bad one. This one's defective, but it's good for just display. It's a foreign ballast tube. Okay, go down to the bottom lower here. Here we have EL34s. These are the famous stereo tubes. These blue ones, if you can get a set of blue ones, boy, they really go good on eBay if you want to do that. But I don't know what the guy paid for them. Carlton bought those. So he paid bunches of money for this stuff. These were made to go in a Beckman instrument. They're electrometer tubes. And you can see what's inside there. That's a pencil tube that's up inside there. And it has a couple resistors and that pencil tube up inside there. And this what's here. This one's been cut open so we can see what's in it. These are Kellogg tube. They're Kellogg tubes. Okay, and here's another homemade triode that I made using that blue glass. Okay, these are sodium tubes. These are the D21, I think it is. And this is what's inside of it. This is what the sodium tube looks like when you just get it. And they fogged up the glass on purpose to foil people from seeing what's inside them. Of course, anybody could break the glass off it. And it turns out, if you're careful, you can pull the glass out of there, heat that up, and you can pull it out of the base and not break it. But these are what's inside of it. It's just a little triode. And they have a little piece of sodium in there. and that supposedly made it work better or something. I think this is a dual delay relay. I'll have to look at it and see, but I think it's got a delay relay in there. It has two sections. One of them closes first, and then 10 seconds later or something, the second one closes. This is a Wunderlich tube of some type or another. It says Wunderlich on the side of it. And here we have a Philips little bitty one. Odd Philips tube. Got connections here and connections there with a why they did that, who knows. Here we have some of the doorknob microwave tubes. These are, I think, all bad. The small one might be good, and this one might be good, but all these others have been tested. This one's got air in it. That one's got air in it. That one's got air in it. But this one and this one have not been tested yet. They may be good. Okay, here we have more of the nice little triodes. These are the similar to 199s in different styles. And this is another one of the ballast tubes. Ballast tube there, the old-fashioned type holder. These were used in radios where you wanted to put a 199 in place of a 01A. And this ballast tube would go in series with the 199, and it would make it equal to 5 volts instead of 3.3. Tubular audions, they called them. This is a real one. You see down inside there the completely ridiculously incorrect aspect ratios of the plates and the grids and stuff. It's a miracle they got it to do anything at all. Same thing with this one. The grid ideally should be as close to the filament as possible, the cathode as possible. And here they have it just the opposite. They got it as close to the plate as possible. And we got different versions of it. These are all commercially made. Okay, here's one. This is a really unique tube. This one, it's a triode, but the grid is on the outside of the envelope. And it uses the electric field going through the glass to modify the field inside the tube. Now, this is an original tube. I made some of these in my tube lab, but this one here is an actual original. It's very rare to the point of, if you got one, you really got it. Then here are some original Marconi triodes. I don't know how many of them are good, if any. Okay, and here's this one here is a homemade Edison lamp. We have the plate inside of it, and we got the filament that arcs up over it. And I don't know if you can see that with the camera. The camera doesn't show the filament up very good. And that gives the Edison effect when you light it up. And this one's good. It can be demonstrated. Here we have another British tube of some kind. Look at that, how they put the elements at an angle like that. Now, this one, it might still have vacuum in it. It looks all white and everything, but this one used a phosphorus as a getter, so that may be okay. Okay, here we have a regulator tube. This one here is a Victorine regulator tube. It's made out of metal, and it regulates at some high voltage, like 500 volts for the Geiger counters. This is just a big light bulb. This is the kind of light bulb that you find up on those radio towers. Here we have big X-ray tube. That's a Coolidge tube, they called it. And it's got the filament and the target and all. And I think it's up to air. I know it's up to air. The base is broken down here, so it's up to air, so it can't be used. I might be able to seal it off and pull a vacuum on it, but I don't know. We'll try it later on. Here we have big transmitting tube, big hydrogen thyrotron. Here's a transmitting tube. Here they brought the grid and the plate out to the side. This one's the plate, and these are the grids. These all here go onto the grid. So you could make that into a good high-frequency amp. Okay, here's a tube that was donated to the collection by, what's the guy in Dallas that has all the knobs? My brain doesn't work anymore. he donated this one to the collection. Thank you. And here we have power triode. This one is, okay, this is another X-ray tube rectifier. It's made to run 100,000 volts, and it works submerged in oil, and they use that in the X-ray machines that use DC voltage on the plates. Okay, big power transmitting tube, a big, huge hydrogen thyrotron, you know, thousands of amps through it. Big transmitting tube, tremendous. Look at the size of that tube. Look how big that sucker is. Look at how big that thing is. That's probably several thousand watts. Okay, then here we have our more common. These are modern transmitting tubes and rectifiers. Okay, and then here we have one that's deceptive. This thing's good for several thousand watts because it is water cooled. And yeah, that can get a heck of a lot more power out of it than if it's air cooled. You know, in other words, this one here is only 1/10 the power of this big thing. So, okay, then down below we got some more rectifiers and transmitting tubes. Great big, these are big ones. Now these are water cooled jobs here. This goes down into a manifold that had water flowing through it. Not water, but they used antifreeze, ethylene glycol, because ethylene glycol doesn't conduct electricity if they keep the water out of it, and that way they could have the high voltage on the plate without it arcing or shorting out or anything. Okay, here we have, look at the size of that thing. Look at the size of that tube. Big transmitting tetrode. Okay, and then here, another big transmitting tube. Humongous, absolutely humongous rectifier. That's just a rectifier. The voltage drop must have been terrible on the thing, but you know, with that much of a plate on it, it could sure pump a bunch of amps through it, probably several amps at thousands of volts. And here's another one. It's a rectifier, and this one here, this is another 2,000 watt light bulb. This is like what you find up. You see those radio towers that have the lights going on and off all day long. All right, the last of the collection. Here we have a homemade mercury vapor rectifier, and here we have a light bulb from 1906. It was used in the street lights, the early street lights. Okay, then here we have a very collectible DeForest tube. This power tube was not made for commercial sale. DeForest kept these tubes in his manufacturing facility. He made these for the induction heaters and things that heated up the elements of the tubes to outgas them. And those tubes were specially made, and he kept them in his own facility and never did sell them. So they don't have any identification or marks or anything saying what they are. Now, the prize of my collection is this one here. This tube is the prize of my collection. This is a Marconi MT9 transmitting tube, and this one here, according to the fellow who got it, Roger Rees, who got the thing, he got it from Glace Bay in Canada, and when they were destroying the station, they were just tearing down the station and getting rid of everything, and he managed to get this tube back in the 60s, and he gave it to me very graciously, and that is the prize of the collection. It is not that rare. MT9 is not a particularly rare tube. You can find them on eBay, but finding one that actually came from Marconi's Glace Bay station, that is rare. Marconi himself may have actually handled this actual tube. You know, there's no way to know, but you know, it was there during the time he was there, and he may have actually handled this very tube. But that is it. All right, now our big tubes, here we got some down below. All right, now that one there, that's a 20 kilowatt air-cooled job, big, huge. Look at the size of that sucker. That's going to be a lot of heat coming out of there. Okay, here we have a 10 kilo, I don't know, 5 or 10 kV one. Okay, here we have a high frequency one. This one is deceptively powerful. This one here is another 20 kilowatt one. It's water cooled. It has connections on it for water. And it's water cooled. Here's another one that's 20 kilowatts, and it's water cooled. And we have more air cooled. These are smaller. They're power triodes. And air cooled job here. And here we have another. This is a low frequency magnetron here. This is the output right here, coaxial output. We're missing the magnet on it, of course, but if it's still under vacuum, then we can get some of the rare earth magnets and stick them to the ends, and they're so much stronger than the original magnet that it'll magnetize it enough to where we can make it work. Okay, here we have another one. This is a couple kilowatts right here. This is a 1500 watt tube, and this one here, heaven only knows how many watts. It's a bunch. And here we have another one, probably 2,000 watts. Here we have a mercury ignitron. Okay, here we have a tremendous tunable magnetron. This one's got the magnets. And all right, this used to have a glass extension here that had the connection going into the inside. So this one's no good. It's no vacuum in it, of course. But that's a high-powered magnetron, probably a megawatt output pulse. And here we have a smaller magnetron, and this one is broken. It's up to air. This one here is loose, so it's up to air. And then here we have a neat little magnetron, tunable magnetron. It's got the magnets, and this one may still be good. It looks like it might still be good, and we'll fire it up if it is. You've got another one right here. This one for sure is good. And then here we have another ignitron. All right, and here we have a huge ignitron. This one here is 10,000 amps average, and oh my gosh, isn't that incredible? I mean, look at the size of that thing. Look at the size compared to my hand. Look how big it is. That thing's 6 inches in diameter and a foot tall. Oh boy, look at that wire on that thing. That wire, it's bigger than welding cable. It's bigger than 4-aught welding cable. Oh man. Oh well. Hey. And it's thousands of volts. The kilowatts that it handles would be incredible. All right.